my channel. In the previous two tutorials, we talked about what is the concept of tensor in Pytorch, and then we also talked about what is the concept of a variable and how can you define backpropagation in Pytorch. In this tutorial, we will talk about how can we define a very simple two-layer neural network in Pytorch. So I've kept these two import statements as it is, as they are pretty useful. In this tutorial, we will introduce two new concepts. So in Pytorch, there is a module called neural network, which will be pretty handy for you to define the neural networks. And then there is another module within the neural network module, which is called functional module. And the way it's generally defined in most of the documentation is as F, and it's very similar to the common theme of importing numpy as np and importing pandas as pd. So we generally import torch.nn.functional as f, and this will be useful to import various activation functions which are defined within this package. So we are going to define a very simple two-layer neural network, and in this video we will all we will do is we will define the structure of the network, and then we will introduce more concepts where we will introduce how you can initialize this network, and then we will also talk about how can we actually train this network and see its output. So to first of all, to write a neural network, we have to first of all create a class for it. So let's say here we can say two-layer net, and it has to inherit from neural network module, so which is the sub parent class. We then need to define the init object, and here you can define the number of inputs of this network, the number of hidden units or the dimension of the hidden units you want, and then you can also define the number of the output you want from the network. So to initialize the neural network, you first of all have to call the super method. So we can do like this, and okay, we then need to define two layers. So here I will define only simple linear layers, and as I said previously, your nn function module will be very handy for you. So I'm using linear layer, which is already defined in the Pytorch package, and the dimension of the linear layer will be the dimension of the inputs and the dimension of the output, which is the hidden dimension over here. And then I have a second linear layer which I will call linear 2, and this will also be based on the number of hidden units and the number of output units. So you can see we have two layers over here. We will then define a forward propagation or a forward pass for this network. So the basic building blocks how you need to define a network is you have to have an init module where you will define your variables, your different inputs, and you then need to define the forward pass, that how the network should predict for a given input. And for defining a forward pass, you have to take an input. So let's say x is our input. So we'll define the output as like this. So we'll first of all compute ReLU over the initial input. So we'll pass the input to the linear module, which is x. We will then do the prediction based on again we will call the second linear module, and we'll pass the previous hidden output, the hidden ReLU, and we will return the y prediction variable. So you see what we are doing here. So we are using the init module to define the two modules which we have. So we have two linear layers, and we are then defining a forward pass of this network, so that given a new input, how that forward pass will look like. In the later tutorials, we will talk about how you can initialize that network. We will also talk about how we can actually train this network. So thanks for watching this video, and please subscribe to my channel for more videos on this topic.